Hello everyone. So in this video, let's discuss problem C of Codeforces around 1002. Let's first read the question and then we'll discuss, derive the solution and we'll go through the implementation. So the question says Nicker, if I pronounce correctly, has started working as a queue manager at the company Black Contour. He needs to choose the order of servicing customers. There are a total of n queues, each initially containing 0 people. In each of the next n moment of time, there are two sequential events. So there is some n queues, and every nth time, these two events are happening. So events are new customers arrive in all queues. More formally, at the jth moment of time, the number of people in the ith queue increases by a positive integer a of ij. Okay. Nicker Niker chooses exactly one of the queues to be served at that moment of time. The number of customers in this queue becomes 0. Let the number of people in the ith queue after all the event be xi. Niker Nicker wants max of the collection x1, x2, xn to be as large as possible. Help him determine the maximum value he can achieve after optimal order of servicing the queues. Okay, basically the question says like there are n queues. Like if I suppose n is 4, then there are 4 queues where at every moment of time some people are coming like 1, 2, 3, 4, 5, 6. Like here n is 4, then it would be up to 4 only, sorry. So here suppose 5 people came, then 4, 2, 7. Then we can entertain one of this queue, like we can empty this one, like we can serve this one, so this will become 0. Then again, some people will come, like 2 people came, then total people are 7. If 3 people came, then total becomes 7. 4, here 4, 5, then it is 12. Then we can entertain any, again, out of 5, we can entertain this one or this one. Suppose we entertain this one, so this becomes 0. Then comes X, Y, Z, A. So like this, it goes up to N. Now, after we perform the operation, suppose these are the final list peoples. So we have to find the max for this. Like here, if you see 0477, the max would be 1 because the smallest integer that is not present in this set is 1. Now, the main requirement is to maximize this value. Like wants max of the collection to be as large as possible. Okay. Now, how we can do that? To understand this, like let's go one by one. Let's erase everything. We will take the same like n equal to 4. So there are 4 queues. Suppose in one of the queues, the last element, like if it is T1, T2, T3, and T4, last element is 1. In out of these 4 queues, suppose in one of the queue, the last element in the means the last time total number of people coming for service is 1 and rest is not equal to 1. Suppose it can't be 0, like suppose 2, 5, 18, and anything here x1, x2, x3, y1, y2, y3, z1, z2, z3, here x p1, p2, p3. Then what would be the best possible scenario like seeing this case? We don't want to lose this one. So at, we will at the third time we will service this queue. First Q1. Suppose these are Q1, Q3, Q4. So we will not want to miss this one. So we will service when T3 time will come. So this whole sum at that point of time will become 0, like x1 plus x2 plus x3 at t3. We will serve this and make this as a 0. So when this 1 will come, this will sum it with 0 and become 1. So at the end we have 1 here. And rest we can serve any, like at any 3 times we can serve one by one. Like let's suppose first we serve this one, then this one, then this one. The second last time we will serve this, remember, so that the last one will remain here. So here the max would be like set we have 0, 0, 0 and 1, right? So max here is 2, which is the maximum possible for this. Anything you will do, you can't achieve max more than 2 here. So from this we can observe that one which is coming at the last has some importance, okay, which we need to have in our mind. Now let's take the second case. Also, what would be the best answer here? If you see what could be our best, like maximum max, it it should look like this, like 0, 1, then it should be 2 and it should be 3. So here max would be 0, 1, 2, 3. So max would be 4, which is equal to n. So the maximum max we can have is like n, up to n. Answer. Now let's see for other case. Hmm, let's erase all. Same n equals to 4. 4 queues are there. T1, T2, T3, T4. So suppose in any of the queues, like last element is 1 and two last element, like last and second last, are 1 1, and rest are some numbers, random numbers, z1, z2, z3, z4, p1, p2, p3, p4. So here what would be the optimal approach? Optimal approach would be to have these numbers at the end. Like this one, as I explained before, should be remain here after T4. So we will serve this as T3 times. So that it one will be remain here. We will serve this as T2 times, so that this 1 plus 1 2 remains here, and this we can serve at T1 or T4 time. So it will be 0 0. So here max would be 3, which would be the maximum possible. So we can observe that this one has very important feature. Suppose here 2 2 2 1 or 2 2 would be there, then it would be greater than 2. So our max would be 1 only. 2 only, like 0 1, and this would be some non-zero, like greater than 2, then max would be 2. From this we can observe that we have to like manage the count of last ones in every queue. In every queue, if there are no ones at the last, like these are 5, 6, 7, 8, then we can't do anything. Like our max would be 1 here, because we will serve one of them at the last, that will become to 0, and rest will be some greater than 1 positive integer. So max would be 1 here. Otherwise, we will have maintain the set where we will enter the total number of ones in every queue, that last count of ones in every queue. Here it is 1, here it is 2, then suppose here it was 3, and again 3, 3, 3. Then we will see how much we can add. So here we can make use of like 1, 2, 3, and this 3 we can serve last. So 0, 1, 2, 3. So max would be equal to 4. So this was the like thinking of solving this problem. So I hope you understood it. Kind of not intuitive, but you have to observe things correctly. If I saw the code, then it would be much more clear. Okay, so I input n, then I input a in a 2D matrix. If n is 1, like there is only one queue, then we can't do anything. Like if there is only this queue, then at the end we will serve, then it will the total sum like remaining will be 0, so max would be 1. So if n is 1, then answer would be 1. Otherwise, I will have one multiset for every queue, like n queues. I will start from last element and I count how many ones are there. So count will store the number of ones I have, and I will, if it is non-zero, like more than zero, then I will insert in my set. So if my set doesn't contain any elements, then as I explained, like every element would be some more than one element, like 5, 6, 7, 8. Then at last we have one of them as a zero, so answer would be 1. Otherwise, I will iterate through this my set and try to maximize the max. Like I will see the first element, if it is 1 or greater than 1, then we can have max as 1. If I have 2, after 1 I have 2, then I can use that 2 also and 3 also. Like this we will increase our maximum answer would be n or max. So minimum of n or max would be the answer for this question. I hope you understood this problem. So if you have any doubt, you can ask me in the comment section. So please like and subscribe so that I will continue making such videos. Thank you.